This is a reminder class connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and participate, but please do not share personal information during these sessions for security reasons. Okay, at this point, you should have your attendance ticket open. That is linked in the chat box. The password is there as well. Make sure you use a capital letter for that first letter for your password. Remember, I only provide this in the recording. So if you miss class, unfortunately, you will not be able to do the attendance. Oh, hey, what are you doing? Today we're working on the net force lab. All right, you guys are lucky. You actually also get 2 game days this week. So tomorrow we will have another game day where you can get some extra credit. New students, now you're going to be able to really understand what's going on in class. So hopefully you'll feel pretty confident tomorrow, now that you've actually been here to learn some of the material, unlike Monday. If you were a late start student who just started on Monday, please make sure that you complete your STAR 360 exam. There are some of you who started school on time but still have not yet done this. So please make sure you go to your grades tab, make sure you get it done. Instructions are also in your grades tab. So we are looking at friction, gravity, and forces. We talked about vectors yesterday, and today our lab is going to take a little bit more of a look at vectors. So today we should be able to determine the magnitude and direction of net force on an object using vectors, and we should be able to demonstrate how different forces acting on an object influence the object's motion. I'm so sorry, guys. Hold on one moment. All right, guys. Sorry about that. Can you hear me? Okay, awesome. All right, perfect. Okay, so let's go ahead and get started with that. So reminder, vectors have both magnitude and direction. And remember, magnitude means amount. All right, and we learned yesterday that forces can be represented with vectors because they have both magnitude and direction, right? The magnitude, the amount of force, and the direction, where it's pushing or pulling. Okay, smiley faces if you guys remember that from yesterday. Talking about, okay, now when we add force vectors together, the final result that we get when we combine them all together is what's called the net force. So another word for net, we can think of this as the total force, and the total amount of force. So for example, you can see over here that if I have one person pulling with 5 newtons to the right and one person pulling with 10 newtons to the right, they will combine and work together to create a net force that's even larger. Smiley faces if you can see how that happens. Smiley faces if you understand how those two forces combine to create a bigger force. Yeah, they're working together. Awesome. Now, even if, Demonte, make sure you're in the room chat. Okay. Now, on the other hand, sometimes forces can work against each other, right? So if we have one person pulling to the left with a tiny force, and another person pulling to the right with a big force, overall, the object still goes to the right, but not quite as much as it would have if it was only the 10 Newton force, because something is working against it. Okay, so something's working against it, so our net force ends up being a little bit smaller, overall going to the right. Okay, now these are situations in which the forces are not balancing or canceling each other out. So we have a net force, and the result is the object will move in the direction of that net force. So for example, this top one, which way is this object going to move? Which way do you guys think this object will move? If our net force is 15 newtons to the right, which way will the object move? Yeah, absolutely. It's going to move to the right. You are totally correct. Same thing with this one right here. Because the net force is moving to the right, pointing to the right, then the object will move to the right. Now, that's for both of these, unbalanced. Now, on the other hand, sometimes our forces balance out. So let's say we've got one person pulling to the left with 5 newtons, and the other person pulling to the right with 5 newtons. Think about this as a tug of war. Will either of those people win? Will either of those people win? Person on the left, person on the right, both pulling with the same amount of force. No, nobody wins. So in this case, those forces are going to actually cancel each other out, and our net force is going to be 0 newtons, which you can see right here. And if it's at 0 newtons, that means that that force is not going anywhere. So therefore, exactly, Lily, it's going to stay at rest. It's going to stay in the same spot. Okay? Give me a thumbs up if that makes sense. Unbalanced forces. Awesome. Okay, so let's go ahead and actually try to figure this out. So for example, if I have 2 newtons going to the left, remember that technically this is in the negative direction. So I can actually mark this as -2. And I have 8 newtons going to the right. That's going to be +8 because it's going in the positive direction. Left is negative, right is positive. Let's combine those together. -2 newtons and 8 newtons gives me what? -2, tell me in the chat box. 8 gives me what? Yeah, exactly. It's going to give me 6 newtons. And in this case, this 6 newtons is positive, so my net force goes in what direction? My net force is actually going in what direction? Let's draw this out. Yeah, it's going to end up going to the right. We have +6 newtons going to the right. Smiley faces if you understand how we got that answer. Okay, let's try this next one. All right, so we've got 10 newtons to the right. Again, that's positive. And also 2 newtons to the right. That's also positive. What do you guys think this would be? Tell me the amount and the direction. Tell me the amount and the direction. Yep, remember the direction, guys. Yeah, you guys are totally right. Yeah, this is definitely going to be 12 newtons to the right because it's positive, right? +10 and +2 give you +12. Now, why did I draw this arrow so much bigger? Why is this arrow right here so much bigger than the arrow above it? Tell me in the chat box. This arrow is so much larger than the arrow above it. Yeah, because it has more force. Remember, a bigger number, that means there's more magnitude, right? So more magnitude, so a bigger number, means that the arrow needs to also be bigger. Okay, smiley faces if that makes sense. Okay, more magnitude, bigger arrow. Awesome. Good, all right, what about this one down here? Letter C, we've actually got -8 newtons and +8 newtons. What would be the net force here? What would be the net force here? Yes, don't forget those units, guys. I see a lot of naked numbers. Put some units on those numbers. Yes, this is going to be 0 newtons. Net force in this case is 0 newtons. So which way does this move? Which way does this block move? You're correct. Yep, it stays at rest because there's no forces working on it. Awesome. And last but not least, this one can be a little bit more complicated. So what I want you guys to think about, and I'm going to add my negatives and my positives here. What I want you guys to think about is that these two on the right actually work together. So +5 and +3 actually gets us a total of what? +5 and +3 would give me a total pulling to the right of what? So I can actually kind of ignore these and combine them together. Yeah, this is actually going to be +8 newtons in total. Okay, so now go ahead and try to calculate that. What's my final answer here? If overall I've got 8 newtons to the right, and overall I've got 10 newtons to the left, what does my final answer equal? Yes, it's going to be -2 newtons, and what direction does that go? This is -2 newtons, so what direction does that go? Oh, you guys got it. Can't even trick you guys. Yep, this is going to be a teeny little arrow going to the left. Awesome. Okay, give me a smiley face if you feel like you really understand what happened on this slide. You feel pretty confident about this. Yeah, you guys just did so much math. You guys are so good at that. Look at what happens when we work together. Okay, perfect. So let's go ahead. We're going to make it a little bit more complicated. Okay, it's not that bad though, guys. And what I want you guys to actually focus on, all right, is first, let's focus on the top and the bottom. Okay, because we always want to combine the purple first and then the orange first. I mean, you can do it the opposite way, but left and right get combined and top and bottom get combined. Thumbs up if that makes sense. Left and right get combined and then top and bottom get combined. Okay, so focusing here, guys. We see at our top we have +45 newtons, and on the bottom we have -45 newtons. So what happens with our top and bottom? What happens with our top and bottom here? +45 up here, -45 up here. What happens with our vertical motion? Yeah, exactly, nothing. It just cancels out. So I'm going to actually go ahead and just cross these out because they are not important in this diagram right here because they're actually canceling each other out. Perfect. Now, what about here? Okay, we can see we've got 45 newtons going to the left, so that's negative, and 15 newtons going to the right, so that's positive. So overall, what do I end up with here? Yes, exactly. You guys are correct. So our net force overall ends up being negative 30 newtons. And I really should draw that a little bit smaller, because remember, it's a smaller magnitude, but I'm having trouble with my arrows. Nice. Okay, so this right here is my net force. Negative 30 newtons to the left is my net force. So many pieces if you feel good about that. Again, you guys actually just took care of 4 directions this time. 4 directions this time. Yeah, awesome. Okay, now this is where it gets a little bit more confusing. Remember that when we have an object going up, with a force going up and a force going to the right, it can't actually go in both of those directions at once. Remember, when we have it going up and to the right, it actually doesn't go up or to the right. Which way does it go? Which way does it actually end up going? When they combine together, remember they're combining together. Which way is it actually going to go? Yeah, it's going to go diagonally. So it's going to actually end up somewhere in between these two. Smiley faces if you guys remember that. Because we combine these, it actually ends up in between the 2 arrows. Okay, now this is a little bit crazier than yesterday, because what I want you to see is that one of these forces is much stronger. Which one is stronger, the 150 or the 250? Which one is stronger, 150 or 250? Yes, the 250 one is much stronger. So in this case, instead of going straight down the middle, okay, it's not going to go straight down the middle like we saw yesterday. Instead, this time, it's actually going to go more towards the stronger one. Okay, so I'm actually, when I draw my diagonal, I'm actually going to draw the diagonal more towards the stronger one. Still in between the 2 arrows, but closer to the stronger arrow. Okay, give me a, let's see here, give me an LOL if you understand that. Still between the 2, but it's going to be closer to the stronger one. So closer to the 250. Excellent, looking good. Okay, guys, I'm going to go ahead and skip this one just because I want to make sure we get to our stuff today. But grab your whiteboard tools. All right, I want you guys to go ahead and match up what we learned on the left with their definitions on the right. Grab those tools. Let's tackle this together. Let's see what we get. And, all right, I'm going to pause tools in 5, 4, 3, 2, and 1. Oh, no problem. Yeah, here you go, Jasmine. Yeah, if you come in a little bit late, sometimes I forget to keep on pasting it in the chat box. So as always, you can just ask and I can get it to you. Cool. All right, guys, let me go ahead and clean this up a little bit so that I can make sure we have the correct answers. And here we go. Gigantic red marker. And here we go. Vectors, yes, they show both magnitude and direction. When we have unbalanced forces, remember that you end up with a net force, so the object will start to move. And if you do have balanced forces, then the net force cancels out, so you have 0 newtons, and so the object. Demonte, I was just telling Jasmine that if you ever come in late, you can just ask for the password. It's just, I forget to do it if I don't. That's fine. All right, guys, so this is number 1 in your attendance ticket. Please go ahead and complete that and save number 1. Give me a green check when you have number 1. You guys have. All right, just waiting on a few more green checks. Abby, Ash, and Ash, both of you. CJ, Carla, Chandler. Okay, Christian, Christian, just take a picture of this. Okay. Okay, good, Ash. Yep, awesome. Yeah, guys, if you ever have trouble opening it, just make sure you take a picture. Christian, you're accidentally private chatting someone else. Can you make sure that if you need to private chat, you just private chat me? Double click my name. Here you go, Cam. There you go. No problem, Christian. It happens. Awesome. All right, guys, let's go ahead and keep on going. All right. So we just reviewed all about vectors, and the reason we did that is because our lab today is going to take a look at vectors, at forces. So today what we're going to be taking a look at is how do forces interact when forces are opposing each other, or they're trying to move an object in a different direction. Okay, so remember that based on how forces combine, whether or not they're working together or working against each other, that overall direction the object will move will be the net force, okay, the total force, right? So for example, if we think about this, let's say we're trying to move a fridge with a friend. Let's say the person over here on the left is pushing to the right. In order to help this person, then the person on the right should pull which way? This guy over here should pull which way? To the left or to the right? Which way should this guy apply a force? Yeah, also to the right. Exactly. So if you want to work together and make this easy, right, both of these guys need to be either pushing or pulling to the right. They both need to be going to the right. Smiley faces if that makes sense. That's going to make it easier to move the object. Awesome. Now what happens is, let's say this guy's pulling to the right, but this guy over here suddenly decides that he also wants to pull, and so he starts pulling to the left. Now what happens to the fridge? Yeah, exactly. In this case, it's just going to stay in place because they're working against each other. They're opposing each other. Even if one of these guys is stronger, it might start to move in the direction of whoever's stronger, but it's not going to move quite as quickly because it has a lot less force overall. Okay? All right, so that's what we're going to be taking a look at in today's lab. So here's the deal, guys. Today's lab is super easy. It's the easiest lab in the course. All right, I already have a worksheet set up that you guys are going to fill out, and it's a drawing one. All right, so it's super, super easy, guys. Smiley faces if you understand. Remember, labs are 25% of your grade, so this is a really good way to get a lab grade in. So if you haven't turned in any of the other labs, you absolutely need to start turning labs in. Okay, without labs, the highest grade you can get is a C, and that's if you do absolutely perfect, which we know if we don't do absolutely perfect, that's going to lower your grade even further to a D or an F, and it's going to be really difficult to pass. You have to do at least some of the labs, preferably all of them. Okay, I know, no one's perfect, and I understand that. We take that into account, but that means that's why it's so important to make sure you do a labs. Just do labs. That way you just have that extra little bit to make sure you pass the class. Okay, so here's what's going to happen, guys. You are going to have a couple things to open up. All right, so I will be giving you the instruction video in a moment, but when you do this, you'll need to have three things open. You're going to need to have your lab report open. Okay, you're going to need to have your virtual link open where you actually do the experiment, and you're also going to have open your Google document, which in this case we're not using Google spreadsheets today. Today we're using Google Drawing. So we're going to actually make a drawing. Smiley faces if you understand this. You're going to have three things open. Three things open. I just wrote them at the top of your slide here. Good. Okay, so I'm going to go ahead and I'm going to actually put all of those things in the chat box. Okay, just so that you have them. I do show you in the video how to get to all of them, but it's helpful for me just to give you the links right now, right? Hopefully you guys find that helpful. All right, so there's the lab report. Here's the virtual link. And then the last thing is the worksheet where you're actually doing your drawing, the Google drawing. Okay, smiley faces if you got those three links. If you understand that all three of those will need to be perfect. Okay, guys. So what I'm going to show you really quick is I'm going to show you what happens when you open up the Google Drawing. So when you guys open up the Google Drawing, it's going to ask you if you want to make a copy, and you do. Okay, so you're going to go ahead and click where it says make a copy, so that you have your own copy in your Google Drive. Okay, so you're going to click make a copy, and now you guys can see this worksheet. Okay, give me a green check if you guys were able to open that, make a copy, and see that. Green check if you guys were able to see this. I already did a lot of the work for you guys. Already there for you. Okay, no problem, Ash. Just as always, just to have those links saved. It's also in your actual lab report. So as long as you have your actual lab report open, you can get those links later. Okay, Sharif? So you'll just have to make sure that you open it a little bit later from your actual lab report. The video will show you how to do that. I do want you guys to make sure that you correct the title up here. So delete the part that says copy of, and where it says your name here, please make sure you actually type your name. And then a couple things that you do need to know about this right here, okay, is that when you want to draw on here, you're going to use the scribble tool. And the way you get to the scribble tool is you click on this little arrow next to this line, and that gives you the option to choose scribble. Okay, so you're going to choose scribble, and now you can actually draw on the whiteboard or draw on your document. And then if you need to type, you can also click on the text box, and that allows you to type on your document. Devonta, you have to make a Google account. That's one of the things that I'll show you in the video, but everybody has to have a Google account in order to do our lab. Okay, it's one of the requirements of this class. Yeah, awesome. Yeah, there is a recording for this, Ash. No, I'm going to give you the recording right now, okay? I just want to make sure you guys know what to do once you see this. Awesome. Okay, guys. So here's going to be the instruction video. Okay, instruction video takes you through every single step. Every single step. It's very, very easy as long as you watch the video. You have to watch the video, though, guys. You have to watch it. I'm sorry. I know sometimes it's tempting to try to skip through the videos. Don't skip through it. Actually watch the video. It's very easy as long as you follow along. All right, so, oops, here we go. So I'm going to go ahead. I'm putting this in your chat box, and then I will also put it on your whiteboard. So here is the instruction video. Okay, so there's the instruction video. I'm also going to put it up on your whiteboard, and we will come back to class at 1:28, and then I'll give you the last word in your attendance ticket at 1:20.
Hello students, this is the instruction video for how to complete question number 1 on your NetForce lab, which is the only question, so this will cover the entire lab report. So first thing you need to do is open up your lab report, so you're going to go ahead and click where it says Unit 3, Application of Forces, underneath our class content box. And once that goes ahead and opens up, you're going to go ahead and scroll down until you see where it says right here, the 3C lab. Go ahead and click that, and once you click that, you'll see a button at the bottom that says Start Quiz. So I'll show you what that looks like. Ignore this screen, but there we go. All right, so you'll come here, scroll down, and you'll see where it says Start Quiz. Okay, and that'll open up our lab report, and we will have that ready to begin. And again, you can see there's actually only one question here. So we need to go ahead and follow the instructions up here. I do want to show you how to make sure that you open everything that you need. So you're going to go ahead and first off click where it says click here, link to the NetForce Virtual Lab. That will give you the link to go ahead and open up this screen right here where you can actually see the lab report. Sorry, let me make this a little bit smaller. You can always use your browser Zoom because I know sometimes that it can be a little bit hard to see everything. So once you're here though, you're going to go ahead and click Begin Lab, put on your gloves, and then click where it says Start. And remember that this does work best in Google Chrome. So if you're having trouble making it work in Firefox or Internet Explorer, try it in Google Chrome. Okay, so this is our lab right here, but I do need to make sure that everything else is also opened that I need. So we have our lab report, we have the place we're actually going to do the experiment, and then we also need to actually open up where we are going to do our drawing for this worksheet. So what we're going to do is we're going to click right where it says click here, make a copy of the NetForce Google Drawing. So we're going to go ahead and click that. And then here it asks you if you would like to make a copy. Remember, you do need to have a Google account. If you don't have a Google account already, remember you need to make one, and we do use it in every lab, so you need to make sure that you have a Google account. So make sure you're logged into that so that when it asks you to make a copy, it sends you to the right place. Okay, so you'll click yes, I want to make a copy. Okay, and then from here, it now has created a copy of the worksheet that you're going to be completing today. So the first thing that you need to do is you need to correct the title up here. So you're just going to go ahead and delete this part where it says copy of, and then where it says your name here, you're going to actually type your name. So for my example, I'll type Mrs. Larkin. Okay, but you need to type your own name right there. Awesome. Okay, so now what you're going to do is you have all three things that you need to have open. You have your lab report, you have the place you're actually going to be gathering your data and results, and then you also have the virtual lab right here. Okay, so we're going to go ahead and follow the instructions now. So I'm going to go ahead and move this over here. And you can see that the instructions are right here in your lab. So it says first thing that you need to do is you need to fill out the masses for each color. And I'm going to show you how to use the scale. But an important thing to remember with our scale that we're going to be using today is that the numbers actually get bigger when the lower the scale goes. So it's a little bit opposite of what you're used to. So I'll show you that in a moment. Okay, so we can see our 10 weights here, right? You have the silver, the black, the orange, yellow, green, and then brown, light blue, dark blue, purple, and red, okay? So what we're gonna go ahead and do is we're gonna go ahead and zoom in here so that we can actually see our scale. Again, if you need to zoom even more, you can always use your browser zoom to zoom in even more. Okay, and we're going to go ahead and grab our first weight here. So this is going to be our first mass here. So this is going to be our silver mass. And all I need to do is I'm going to go ahead and right at the hook, I'm going to hold it over that and click. And that's going to make it attached to our scale. So now looking at our scale right here, we can see that this line at the top of this kind of red stick that we see right here, this line is going to be our mass of this silver mass, okay? So I'm going to zoom in again. All right, so you can see that it's below the 20 mark, but it's also a little bit higher than this middle mark between 20 and 25. So I do have on your worksheet, I do tell you what each of those marks means. So if you want, you can always make this bigger just so that you can see it while you're working. Okay, so you can see that this second mark right here is actually the 22.5 mark, okay? So what you can see is that our mass has to be somewhere between 20 and 22.5. Again, this is a little bit hard to think about because actually if you're below a dash, your numbers are actually getting bigger. So our number here, because it's below the 20 Newton dash, actually needs to be bigger than 20 newtons. So here what I'm going to say is that this is probably, since it's below 20 newtons, but still above 22.5, I'm going to guess that it's going to be about 21 newtons. So for silver, I would go ahead and enter that this is the 21 Newton mass. Perfect. So now I'm going to go ahead and do our next one. All right, so I'm going to go ahead and grab this and grab our black one right here. Oops, sorry, got to zoom out a little bit more from my browser. There we go. All right, so we're going to go ahead and grab our black mass and we're going to go ahead and drop that onto our scale and zoom in here just so I can see everything. Awesome. So again, what you can see here is that this is going to be a little bit below this middle dash right here. Sorry, I'll use the thumb. So it's a little bit below this middle dash right here, which if I look at my diagram right here, that middle dash is 17.5. So if it's below 17.5, that means the number should be bigger. So since it's a little bit below 17.5, I'm going to choose a number that's a little bit bigger, which would be about 18 newtons. Okay. Awesome. So let's go ahead. I'm going to do one more of the big ones with you. So here, let's do the orange one. Drop that on. And once more, we can kind of zoom in, zoom in. Oops, sorry. I need to zoom out a little bit just so I can move this over. There we go. Now zoom in. Perfect. All right, so what we can see here is that this one is actually exactly on 15 newtons. So this one's easy. This one is going to be 15 newtons. Good, so that's what we have right there. All right, so let's go ahead. You should be able to do yellow and green on your own. I'm going to go ahead and do a couple of the smaller ones just because the smaller ones are a little bit harder to read. So for example, let's do the red one. Okay, and if I zoom in here to take a look at this, oops, sorry, zoom in here to take a look at this, you can see that this red one is pretty much exactly on this line right here that you can see up here. So that line is 2.5 newtons. So the red one should be 2.5 newtons. Okay, and you'll notice that we all have the same weights, so you should be copying these ones, but remember you do have some of them that you need to do on your own. And then let me go ahead and do the purple one for us, just to make sure we really know what we're doing. So I'm going to grab this purple one, drop that on the mass. Sorry, I need to move over again a little bit. There we go, move over again a little bit. Zoom in, Perfect. And what we can see here is that if I move up, it's now below, a little bit below 2.5 newtons. And since it's just a tiny bit below 2.5 newtons, I know the number should be a little bit bigger than 2.5 newtons. Again, when you go below, the number is actually bigger. Okay, so in this case, a number that's a little bit bigger than 2.5 newtons would be 3 newtons. Okay, so what you should see here is that as we go from left to right in our weights, we should see the numbers go from bigger to smaller. If you see for some reason that that pattern doesn't happen, then you've measured it incorrectly and you need to retry it. Again, always remember that I have these middle dashes labeled, and that if you have a number below a dash, you need to actually choose a number that's higher. Okay, if the scale goes below a dash, you have to round up to a higher number. All right, so you guys should be able to do, sorry, I'll do one more. I'll do the dark blue one for you just so we have 3 of the big ones and 3 of the small ones. So let me grab our blue one here, our dark blue one, right like that. And then looking at that, so this one right here is a little bit further below the 2.5. Okay, so we've actually already had one that's below the 2.5, but this one's even further below the 2.5. So what that means, sorry, moving over here. What that means is that this one's going to be even bigger than our previous one. So our previous one was about 3. So in this case, this one's even further below. So I would call this one probably about 3.5 newtons. Okay, and I can make this box a little bit bigger. Good. All right, so again, you should be able to do these other 4 on your own. And again, they should be getting smaller from here, right? So 21, 18, 15, this one should be smaller, this one should be smaller, brown should be smaller, and light blue should be smaller. But if you, for some reason the pattern doesn't hold, again, you do need to remeasure because you did it incorrectly. Okay, so now we have our weights. All right, so you're going to go ahead and fill in all of those weights. And then what you're going to do is you're going to choose some of our weights to go ahead and go to our lab. Okay, so sorry, over here. All right, so what you're going to do is you're going to choose some of our weights to, sorry, there we go. I got rid of that. To go ahead and move to the table where we're going to do our experiment. Now you can't fit every single weight on here, so you're just going to have to choose some random ones. Okay, so for example, I might choose the silver one. Actually, sorry, I'm going to choose, yeah, I'll choose the silver one. I'll choose the orange one. And for now, I'll choose the, let's see here. Actually, sorry, I'm going to switch this. I'm going to choose the black one. Again, these can be random, but I'm just doing this. All right, so I'm going to choose, here we go. I'm going to choose black, orange, and purple. Now you should choose different ones, okay? As I've stated, please don't copy my examples. All right, so please choose different weights than me. Okay, so that's extremely important. Do not choose the same ones as me. Okay, so once you have your weights though, again, you can fit, I think, up to about 5 of them on here, but once you have your weights, you're going to go click where it says go to table. So we're going to go to the table. And now we are at a new section right here, okay? So what we're going to do, you can ignore this little block on this table. We're only going to pay attention to this middle block right here. So what we're going to do is we're going to first add a single mass to one of our sides. So the way of this block, so the way that we do this is we are going to go ahead and click on one of the masses. So for example, I might choose our black mass. And then all you do is you choose which side of the table you want it to go over, and you just click over on that side. So in this case, I have the 18-pound block over on the right side of my table, or sorry, the 18-Newton block on the right side of my table. Yours should be different. If I see that you have the 18-Newton weight on the right side of your table, I'm going to know that you were using my example and you'll get a 0. So please use a different example, put it on a different side of the table, use a different mass. Okay, so I have my 18 Newton weight here. Now I need to actually draw my result here. So this is number 2. So I'm going to go ahead and grab where it says up here, you can see there's a little arrow next to this little line right here. So you're going to go ahead and click on that arrow, and then come down here and actually choose scribble, okay, because scribble is going to allow us to actually draw freehand on this diagram. Okay, so I'm going to go ahead and click that. And what I'm going to do is this represents that wooden block in the very center right here. So I'm going to show that on this wooden block, currently I have a 18 Newton mass pulling to the right. Okay, so I'm going to draw an arrow to the right, and then I'm going to go ahead and write here where it says text box. I'm going to go ahead and write that this was the 18 Newton mass that's pulling to the right. Awesome. Now what we're going to go ahead and do is we're going to go ahead and let go of the block and see which way the block goes. Okay, so I'm going to go ahead and click on this hand right here. And you can see that the block flies off to the right, which means, as we've learned, that when whichever direction your block moves, that's actually also the direction of your net force. Okay, so I'm going to go ahead and click on this, and this right here is also the direction of my net force. So click where it says scribble again, and you're going to draw that this is also your net force. So you're going to draw a second arrow, but this arrow you're going to label as the net force. Sorry. You do want to draw your text box because otherwise if you just click it makes a ginormous box. So when you do this, just actually draw your text box. And this is going to be the net force. Okay, so you should have two arrows. Again, yours don't have them pointing to a right. Choose a different type of direction, choose a different mass. Okay, I'm going to write that right here. Sorry, again, I need to remember not to just click. Choose a different mass and a different direction. Okay, make sure you mix it up. Okay, so let me go ahead and highlight that for us really quick just so everyone knows that. Okay, awesome. Now what we're going to do, we're going to go ahead and reset this, and we're going to go ahead and set it up exactly the same as I did in question number 2. So once more, I'm going to make sure that my black weight over here is on the right side. So I have my 18 Newton mass on the right side. But now I'm going to add a second mass on a new side, but it can't be opposite. Okay, so you can't choose the side that's across from your first mass. Okay, so if your mass is on the top, you can't put it on the bottom. You can't put your second one on the bottom. If yours is on the right, you can't put the second one on the left. If it's on the left, you can't put the second one on the right. If it's on the bottom, you can't put it on the top. Blah, blah, blah. Okay, so here my mass is currently on the right. So since I can't choose this side, I can either choose the top or the bottom for my new weight. So I'm going to grab a new weight. So let's choose this yellow one right here. And I'm going to go ahead and drop it on the top in my case. Okay, so now all I need to do is draw what I just did. Okay, so, sorry, we're going to go ahead and move this down a little bit. So grab your scribble tool. You're going to go ahead and show an arrow pulling to the right and label that as your 18. For me, that's my 18 Newton mass. Again, yours should be different. And then I have another one now that's pulling up towards the top, and that one I'm going to label as my 15 Newton mass, right? We learned in our experiment before that this was 15 newtons. Okay, so I have 15 newtons moving to the top, 18 newtons moving to the right. Now I'm going to go ahead and let go and see which way my net force sends this. So what you can see is that my net force is sending this off this corner right here. If you were looking closely, you can actually see that it sends it a little bit more towards this side of the corner. And the reason for that is because the 18 Newton force is actually a little bit stronger. So it's going to actually go a little bit more towards where the 18 Newton force is. All right, so in this case, I'm going to go ahead and draw that. All right. Draw that it went a little bit more towards the 18 Newton force. And this right here, I'm going to label as my net force. Okay. Now, our third situation, we're going to go ahead and add a third mass now. So set it up exactly the same as you did. So I have my black one on the right, I have my orange one on the top, and now I'm going to grab a third one right here, and I'm going to go ahead and make this third one go over here on the left. Again, you can choose either of your blank sides. Okay, make sure that it's an empty side though. And you should have different weights, right? Make sure you're using different masses. All right, so I'm going to go ahead and draw that out. All right, so once more, I have my 18 Newton to the right, I have my 15 Newton to the top, and I have my itty bitty 3 Newton to the left, which my itty bitty 3 Newton I'm going to draw much smaller because it's a much smaller mass. All right, so I've got right here, oops, 18 Newtons. All right, up here I've got 15 newtons, and then over here to the left I've got my 3 newtons. 3 newtons. All right, so now let's let go of this and see which way that this goes. So I'm going to go ahead and let go of my hand. And this time we can see that this time it actually almost went directly off the corner. All right, so once more, this one did go diagonally. Yours might go a different way, so make sure that you're paying attention to which weights you're using and which way it actually goes. All right, sorry, I'm going to go ahead and actually move this right here because it's a little bit in the way of where I'm going to be drawing. But I'm going to grab my scribble tool and I'm going to draw that it actually went straight off to the right. Again, this is a little bit different than this one. This one I showed that it went more towards the 18 Newton force. This one actually went straight between both of these. So right here I'm going to go ahead and mark this as my net force. Now the last thing that you need to do is you need to find 3 or more weights. Okay, so you can use as many weights as you need as long as there's at least 3 of them. And this time what you're going to do is you're going to try to balance these off so that the square in the middle doesn't move. So this takes a little bit of trial and error, or it takes a little bit of math. So if you're mathy, you can probably figure out how this works. But what I'm going to do is I'm going to try to put these so that this block in the middle doesn't move at all. Okay, so, and you might need to go, you might need to go back to your table over here. So you might need to go back to your table to grab a few more weights. So if that needs to happen, you can do that. Okay, so I'm going to go, back to my table over here. And I'm going to, in this case, I'll go ahead and drop my black weight at the top. Again, this is kind of a new scenario. Okay, so this time you can choose new places to put your weights. You can also choose new weights, right? So here, if you want, you can choose new masses and sides now, just for this last question. Okay, so again, these ones can be different from numbers 2, 3, and this should say 5, 2, 3, and 4. All right, so let me go ahead and just highlight that for us really quick. Okay, so you can choose new masses and sides now. All right, anyway, so in this case, I'm going to drop off my, my 18 Newton mass at the top, and because these two are both smaller, I'm going to go ahead and set these on the opposite side to try to balance them off. But I know that since this one is much smaller, that it's probably not going to be strong enough to keep this from falling. So I'm going to actually grab my other small one and also drop it over the small side. So I'm hoping that 2 small masses here will help to balance off a really big mass over here. So I'm going to go ahead and draw that out. First I'm going to go ahead and test whether or not this works. All right, so I'm going to test if that works. And in this case, it does. So I'm going to go ahead and draw that out. So at the top, I had my 18 Newton mass. Okay. At the bottom, I had both my 15 Newton mass and my other mass, which is my 3 Newton mass. Okay. Which really I should draw this one much smaller. This one's a much smaller mass. Okay, good. So what I can see here is that what ended up happening is that because I have 18 newtons pulling towards the top, at the bottom, adding a 15 and a 3 Newton mass together actually also makes 18 newtons pulling towards the bottom. So since we're pulling with the same amount of force at the top and the bottom, this ends up equaling 0 newtons. So our net force here, there's actually no net force. Okay, so I'm going to go ahead and type here that in this case, and this should be true for everyone, in order for this to not move, your net force must equal 0 newtons. So when you label this, again, there's going to be no net force for you to draw, okay, because your block should not move, so you're not going to be able to show that your net force is moving anywhere. Instead, you should be able to say that your net force equals 0. And again, you should be able to tell that based on your math, right? If you have 18 newtons pulling down, with a combination of masses, you should also have 18 newtons pulling up with a combination of masses. Okay, so again, you should use any of these masses. Don't copy my own, but that's going to be what your worksheet should look like. So once you're done with that, okay, we can go ahead and close out of this. If you guys want, there's a fun activity that you can do where you can actually, I'm going to reset the weights there, where you can actually try to knock off these little targets here. So that's always a fun thing to do. You can actually try to knock these off. I can show you what that looks like. And you can try to play around with this because that can be fun to see if you're good at this. All right, so you can see you can knock those weights off. All right, perfect. So I'm going to go ahead and close out of this though. And then the last thing that you need to do, you have your worksheet filled out. You're just going to go down here to where it says this is my shareable link that I copy pasted from Google Drawing. So to get your shareable link, do not use this link at the top. Okay, extremely important. Do not use this link at the top. Instead, you're going to go to where it says share. You're going to click where it says get shareable link. And then right here where it says copy link. Okay, so once you have that copied, you can come over here. You can right click and click paste. All right. You can also click Control and V at the same time. So if on your computer, you should be able to see where it says CTRL for control, and you should be able to press the letter V at the same time. So if you do that, that also pastes it. Or on a Mac, it might be Command V. So you can also do that to paste as well. Okay. All right, so there we go. And then all you need to do is you're going to go ahead and click Go to Submit Quiz and Submit Quiz, and you're all set, and that's it. It's super easy, just that one question that you need to do. Perfect. All right. Thank you guys for watching this. If you have any questions, make sure you let me know.
It will be in the recording later, but if you want to do it now, save the link. Perfect. Okay, guys. Sorry, I'm just talking quietly, Scoots. All right. Looking good. Yes, absolutely, Paulina. Okay, so here we go, guys. We talked about magnitude direction of net force. Oh yes, Ian, it's because my mic has been having issues, so I used a different mic to record the recording. It's a little bit confusing, yeah, but unfortunately that's what had to happen. All right, so let me go ahead and I'm going to give you your last word in a second, but I do want to remind you that when you log off, make sure you complete the 3C lab. That is what is due today. If you're having any trouble opening the virtual lab, please stay after class. I can help you guys figure that out. First off, it does work best in Google Chrome, and if you're having an Adobe issue, I do have a workaround for that as well. Okay, here's your last word. If you guys are all set, I will see you guys later. I'm so happy to hear that, Paulina.